Okay, so last time I was actually doing a lesson, we had an example. And at the end of the example, I had to explain something that was new and different and strange. Usually when we get asked to solve for something, we try to find what x is equal to. And I introduced the new possibility. The possibility that sometimes there is no answer. And that's actually where I'm going with this first set of notes here. So, I mean, for some of you who are writing it down, you might not need to write down everything. Sometimes when quadratics are factored, they factor into nice even numbers. Like this one here. X squared minus 8x plus 12. Totally factorable. You can turn it into x minus 6x minus 2. Why? Well, because 6 and 2 are the numbers that times to give, let's see, they times to give 12, but they add to give minus 8. A lot of times you can actually factor something. Heck, if it's an equation, we can solve it. If you have x minus 6, x minus 2, we can find what x is actually equal to. But then we have an issue. What if sometimes we can't factor something? And so I introduced last week, I don't know, whatever the day was last week, Thursday or Wednesday, the idea that sometimes we might not actually be able to solve a question. It's not that you made a mistake, or it's not that you're not smart enough, but sometimes it's actually just not physically possible. And the answer is, I'm going to say this a lot, the answer is, there is no answer. And so today what I want to do is I want to introduce to you a formula that can help us figure out whether or not there is an answer or not. Because I think some of you asked me the question, how will I know if there is an answer or not? That's what this formula is useful for. If there's an answer, it will find it for you. And if there is not an answer, it will...
What is that?
They have someone's walking down the thing with a boom whacker. You know what those are? They're like hollow, thin plastic tubes. Yeah.
I honestly don't know what that is.
It's called a boom whacker. They're fun. Like it's a hollow plastic tube that you hit.
Hey, come back.
I close it out. Anyways, long story short, this is our backup method. This is plan B. If all else fails, maybe plan C or D or E, but if all else fails and we think there might not be an answer, we're going to try this formula, and this formula will help us. Let me start by doing an example just to help prove my point. Let's say I asked you to solve this guy right here. Well, we can attempt to solve by factoring. So one of the things I noticed, by the way, when I was looking over assignments, a lot of you struggle as soon as I put a coefficient here. As soon as I put that leading coefficient there, it changes everything, right? Because once you find your special numbers, you're not done. We need to look for numbers that add to give the middle number, multiply to give the first times last number. What adds to give 5 times is to give minus 6. Let's try it. Negative 5, negative 1. Close. You're close. You can see where the mistake is right here, though, right? Try again. That's okay. I like to focus on the one that timeses. There's only a couple things that times to give a 6. A 1 and a 6, and then a 2 and a 3. What are you suggesting?
3, 2.
Let's try it. Let's do a 2 and a 3. That would add to give 5. We got a problem, though. 2 and 3 wouldn't give you a negative 6, though. Okay, so it was a good attempt, though. We're trying to do a 1 and a 6 combo. What did you say? -1. Yeah, try with the negative 1. That might pull it off, right? Because 6 and minus 1 is 5. And 6 times minus 1 is minus 6. Here's what I noticed when I looked over some of your work on assignments. The answer does not just go right to x plus 6, x minus 1. Do not go right there if there's this leading coefficient. Because right off the bat, this x times that x is not giving you 3x squared. So the advice I'd give you, if you struggle with these, we need some practice. But the advice is break this middle term up into pieces. So go with 6x minus 1x. That's what these numbers are for. They're for splitting the middle term into pieces. Okay, then the advice is after you split it into pieces, cut it in half and common factor. So the commonality between a 3 and a 6 is the 3 as well as an x. The leftover bit would be x plus 2. If you do it right, this bracket over here better be the same thing. If it's not, that's actually where we start questioning and saying, is it possible? Sometimes there is no answer. See how both of these have a negative? I could factor out -1. If I factor out -1, it would actually leave me with x plus 2. Because the negative would distribute across both of them, making them both negative. Our final answer, well, we're not quite done, but our final factoring answer is one of these things is x plus 2, and the other thing is 3x minus 1. If it's equal to 0, we can solve. Sometimes I actually write this all the way out. So I could write x plus 2 equals 0, minus 2, minus 2, x equals minus 2. Like, you can write it out if you really need to. Or sometimes you just look at this and go, if it's plus 2, the answer is -2, like you flip it around in your mind. Same thing for this one right here. You'd say 3x minus 1 equals 0. Add 1 to both sides. Divide by 3 from both sides. There, x equals a third. Truthfully, this first example, this is what we've been doing all along. Here's where I want to go next, though. What's the only difference between this example I just did in purple and the one that's down next? Yeah, rather than -2, it's -3. Well, how would you change it? Well, you'd go, we need a number that adds to still give 5, but we need a number that would times to give -9. What if that's not possible? Right? Because what times is to give 9? 1 and 9. That won't somehow get us a 5, though. 3 and 3. That won't get you 5. It'll get you 6. So sometimes you might be wondering, is this possible? So today's the way that we break that down. If we're not sure about it, we use the quadratic formula, and it will either give us an answer and say, no, it is possible, or sometimes the answer is, actually, there is no answer. Okay. What's going to happen with the quadratic formula, you see how these answers right here have often been nice, even numbers like -2, -1/3, something like that? Sometimes the answer is something ugly like 4.082379. And so what this formula is going to do for us is it's going to find us really, really ugly decimal numbers. But sometimes there is actually a value. It's just it's not an even number or like a, you know what I mean, like a completely even number or like a fraction. So we're going to prove how to find this quadratic formula later, but I'm just going to show you how to use it right off the bat. And one of the reasons I do this so soon is actually because of the overlap with kids in physics. We need to do the quadratic formula in physics. Okay, and we need to do it by Thursday. So it kind of puts me on a bit of a crunch. So I'm sorry if not all of you are in physics. We were going to learn this anyways, but the reason why I put how to use it before how we get it is mainly for that reason. Okay, so I promise you, I will show you later where the formula comes from, why it works, all that sort of stuff. But for right now, I'm just going to show you, here's a formula, I promise you it works. Okay? And if you can trust me on that, I promise. I will later show you where the heck it came from. Here's the quadratic formula. And this one's pretty famous. You're going to use this one a lot. So here's the way it works. You have to, first of all, have a quadratic in what's considered to be general form. You guys remember general form? Yeah. It always equals 0, and we always write them with like the x squareds first, the x's next, and the cross terms last. If we know what these numbers are right here, I don't know why we sometimes change between capital letters and small letters, but essentially this A right here, whatever value this would be, it goes into the formula where that letter A goes. Whatever this B number right here happens to be, it actually goes into the formula where the small b goes, and it goes actually 2 locations. It goes in this location and in that location. Oh, I screwed up. A actually goes down here as well too, actually. And whatever the C value happens to be, it also gets plugged into the formula. So it's going to take a little while to wrap your head around these because I'm just going to do a lot of examples today. But the long and short of it is there's going to be 3 things we need to know. Whatever these 3 numbers are in our equation, they get plugged into this formula, and it's going to tell us what x is equal to. Have you guys ever seen this symbol before? Did you not? What does it mean, you know? Yeah, what we do with this symbol right here, this is referred to as a plus or minus symbol. It actually means that there's two things happening simultaneously. You have to find this value right here, and you have to add before you divide, and that gives you one answer. You know how sometimes we have more than one answer? Well, to find the other of the two answers, you find this number, and then you subtract and divide. So this symbol right here actually implies two formulas. One time, you add these two terms. So if you had, like, say, 2 plus 7, the other time, though, you'd have to go 2 minus 7. And therefore, you get two answers. So I'll show you the details on this as we do our examples. Okay. Let's do this example here. We're going to determine what are called the roots of the following function. Have you guys ever heard that notation before? Do you know what roots happen to be? Or is that not a phrase you've heard of before? I'm getting not much here. Okay. Roots means when y equals 0. You've never heard that before? A root of something is when y is equal to 0. So if I ever use that phrasing, what this really means is this y right here is equal to 0. That's all. And if you're finding the roots, essentially then when y equals 0, it means then find x. So we're going to solve for x. So really, this is the same thing we've been doing. I wanted to show you a new way of phrasing it, because you may come across that somewhere. So right off the bat, you could attempt to do this. Find numbers that add to give 7 and times to give 2. And right off the bat, you'd be like stuck, because nothing times to give 2 except 1 and 2. There's no way that adds to 7. So you might be tempted to say, I think we're done. Mr. Shelf, this cannot be solved. Almost. We're not certain of that yet. We're going to use this quadratic formula. So here's how the formula works. This 2 is A. A is going to be 2, because it's in front of the x squared term. B is going to be 7. And C is going to be 1. That's the first thing you do. So you find the numbers that are in front of the A term, the x squared term. The B is what's in front of the x term. The C is your constant term. And that's what helps you know what numbers to go in. I don't know why we go with capital letters for this and small letters for the formula. But, I mean, essentially now it's time to plug things into your formula. So after a while, I promise you, you will memorize this formula. But this is that formula. So let's start plugging in some values. We need minus b. By the way, this is on your formula sheet, by the way. Right. Well, b is 7. So we're going to make it minus 7. Then we write the plus or minus symbol. We're going to deal with the two issues, the plussing and minusing, in a bit. We'll get to that in a second. Then we have to use b again right away. So you actually double plug in whatever b happens to be. So since b was 7, I'll plug in 7 on squared. Then we have to minus 4. Directly next to the 4, we have to times by whatever a is. And since a is the first term, it's 2. And then right after that, we actually have to times by whatever c is. And since c is our last number, that'll be a 1. And the last step for this formula is we need to divide everything, the whole thing. One common mistake people make is they don't draw this line long enough. Make sure that you extend this line across the whole thing. We divide all of this by 2 times by whatever a is again. So 2. Okay, that's the quadratic formula. Now we need to simplify it a little bit because it's a bit nuts. So here's the advice I get. I always put two things together first. I put the bottom together. 2 times 2? Okay, so I'm just going to rewrite this whole shebang, and I'm going to put a formula. That's usually what I start. The minus 7 and the plus or minus symbol, I usually leave that. There's not much you can do there. And then I focus on this stuff right here, and I'm going to do bedmass properly. You guys remember bedmass, brackets, exponents, multiply, divide? We have to do the exponent first. So the exponent is 7 to the power of 2, which is 49. And then the next thing you have to do in BEDMAS is the multiply stuff. So this 4 times 2 times 1, you have to do that stuff next. So 4 times 2 times 1 is 8. And I'm going to leave the subtract till later. So this is what I usually do next. I put these terms together. I find out what this guy right here is. And I find what this guy right here is. That's usually what I do. Now, by the way, you can skip some steps when you get better at this. And then I say, well, hey, 49 minus 8, I can do that. 41, right? When you get to this point here, we now need our calculators. Because I would never expect any of you to get this in your heads. I definitely couldn't. You have to be very, very careful the way you do this, though. So first we're going to start with minus 7. And then remember that add over subtract sign I talked about there? We got to pick one or the other. I don't care which one we pick first. We'll do the other one second. But just pick one of the symbols. So why don't we start by adding the square root of 41. And then we divide by 4. We have now found an answer. And sometimes answers aren't nice even numbers like 2 or 3 or 1.5. Does that make sense? The quadratic formula then is reserved for answers where the answer is kind of a dumb, ugly, stupid number. One of the answers that apparently solves this is negative 0.1492189,406. That is one of the answers that apparently works. I'm actually going to go prove it now. So I'm going to go back up here. Have I shown you guys how to store an answer in your calculator? No. Okay, let me show you this if I haven't seen it before. See down here right above the on button, there's a button that says STO. That means store. Press that button. And then we're going to store this as a letter. I'm going to store it as the letter, I don't know, A, I guess. So I'm going to go alpha and then math. See how there's the A hidden behind here? I'm going to store it as the letter A. And from now on, every time I make the letter A come up, that whole number is going to show up here. So here's what I'm going to do. I'm going to say we need 2 times x, okay, for our purposes that'll be A squared, plus 7 of that number, plus 1. If that really crazy, stupid, ugly, horrible decimal number is the correct answer, what should this equal? Okay. So that's what the quadratic formula helps us find. If the answer is not a nice, even kind of number, and it's a stupid number like this, feel free to call it a stupid number, because it is. The word we should use is irrational, by the way. If it's an irrational number like this, that's what the quadratic formula helps you find. However, there's still sometimes more than one answer. We actually aren't done yet. Remember that whole plus minus symbol we had there? We now need to do the subtract side of it. So we should take negative 7. We should subtract the square root of 41. And then divide by 4. Oops, we need to divide that by 4. Negative 7. Subtract the square root of 41. Divide by 4. And here's another answer that apparently works. Again, it's a stupid, horrible decimal number. The word we should use is irrational. One more time, just to prove to you that this actually will work, I'm going to store this. I'll store this one as b, just to keep them separate. If I go 2 times b squared, what was the equation again? Plus 7b plus 1. If I did it right, it should equal 0. So quick summary so far. The quadratic formula, I will show you where the heck it came from later, I promise. Okay? Because sometimes it's a little overwhelming to go, why are we jumping right into this? But the rationale is, kids in physics actually need to know this right away. So, sorry if you're not in physics. We were going to learn this at some point, I promise you. I'm just doing it right off the bat here. The idea, though, is you can solve any equation that's unfactorable using this formula here. Now, one more thing, though. I have a personal preference. And my personal preference is, let's not bother with these decimal numbers here. Because the first question is, well, where should I stop rounding? Should I stop rounding right here? Should I stop rounding right there? And so to kind of make things a little bit easier for you, I actually prefer it if you leave your answer as this. If you leave it as -7 plus or minus root 41 over 4, I actually prefer that. The reason is that you haven't rounded. And it's almost always preferable not to round the number. So it's going to take a little getting used to, stopping right here and being like, that's my answers. There's actually two answers there. There's a plus and a minus answer. But that's what I want to help you guys work with today. Okay, that's the quadratic formula. Give me a thumbs up, down, or in the middle. Were you able to register after just one example? How do you feel on this? Okay. Essentially, the rest of my lesson is just a whole bunch more practice on this, because the more you do, the more you'll figure it out.
So we're having a test on this.
Sure.
Next one. We got a week to work on this. Okay. Here's a picture I found on the internet. So here's how your quadratic formula works. One more time. If you can write it in the standard form here, these values right here are what get plugged into the formula in various spots. So for example, 2 goes here and here, 11 goes here and here, and 6 goes there. Once you get used to where the numbers go, like practice will help, it will usually give you 2 really stupid looking decimal numbers. Truthfully, I want you to leave it as this. It always looks like this, minus a number, plus or minus something square rooted, all divided by some other number. This is actually 2 answers. I don't see much purpose in making you grab your calculator and find those 2. Okay, before I do some more examples, I want to do a brief aside. I've been mentioning that sometimes it's possible that there is no answer. This would be a good place to show you how there is no answer. That stuff underneath the square root sign, we actually give it a special name. It's called this discriminant. And here's how you can tell if there is no answer. What if somehow all of these numbers right here, you end up at the square root of -2? Can you square root a negative number? This is actually how you can then prove that there is no answer. If after plugging all of these numbers in to wherever those numbers happen to go, you somehow get a negative number under the square root sign, negative number means less than 0. If all of this stuff right here is less than 0 as a negative, then it actually is possible that there is no numbers that'll work. No whole numbers that'll work, no integers that'll work, no stupid decimal numbers, irrational numbers that'll work. So it is actually possible for there to be no answers as well. So let's do some examples. The best way to do this is to practice. So let's do some more. So it says let's find the roots. Again, just to make sure you guys know this notation, roots basically means make it equal to 0. So we're not doing anything new. We could try factoring this, but I think the whole point of this was we were going to use the quadratic formula. So let me rewrite it out again. And if you have a formula sheet, I believe it's on.
No.
Yeah, I'll give you guys one on the very first day of school.
Yeah,
We'll back. It was like one of the million things that I handed you out the first day.
Don't you gave us one.
I did?
No. He's lying. He handed them all to all. You were here like the second day. You were here.
Alright, who needs one? I got extras. Holy smokes!
Not me.
What's up?
I was like,
Randy, can you make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 more?
Sorry, golf.
How can I be that short? You guys must have dropped one at some point. You lost it. You lost it.
We all won, so.
Thanks, Jason. Alright. Well, at least for right now, if you don't have the formula sheet, write it down. I'll get your formula sheet when Bonnie gets back. Okay, let's give this a try. We need to find our b value first. -2, 3, or 8, which one's the b? Good, right? So in both of the locations that we're supposed to have a b, I'll write a 3. Okay. Then a needs to go in here twice. So a needs to go next to the 4 multiplied by it, Include signs, by the way. See how this is a minus 2 right here? We have to include that minus, okay? So we're going to have to times it by minus 2 in both of those locations. And then the c value that's going to go right here is going to be the 8. So sometimes I'll write it like this. We need minus 3 plus or minus 3 squared minus 4. I'll just put a bracket next to those a's and c's numbers just to imply that they're multiplied. Okay, next step. Let's clean it up a little bit, because at first the quadratic formula, until I give you a bit more context, it's kind of gross and ugly. So I would leave the minus 3 where it is. This is just me. And then I would work on these things here. So what is 3 squared? Okay. For the next part here, we need to make sure we get our signs correct. We need minus 4 times minus 2 times 8. Include that minus. Minus 4 times minus 2 times 8 is a positive 64. And on the bottom of the fraction, 2 times minus 2 is minus 4. Next step, we can put those two numbers together, the 9 and the 64. If you can go directly there, I'm okay with that, by the way. You don't have to do this in little bitty pieces, but at first I find it helps just to do it in stages. So I'm going to put the 9 and the 64 together and make it a 73. That is done. However, for a little more context here, that happens to be equal to a really dumb negative number. It would be minus 3 plus the square root of 73 divided by minus 4. If you actually wanted to have a decimal number answer, that would be what it is. I don't want the decimal number value. I don't see any value to it because you have no idea when to round. So until we get a little bit more comfortable with this, this may sound strange, but I just want you to stop right here. I'm good with that.
Hands up, guys.
Yeah, top. Paper airplane.
Must have ran out of sheet.
Now we all Alright. This was one of the answers. Don't forget though, this notation really does imply there are two answers. Because one of the answers is when you add the number, and the other number is when you subtract. So you can always go back and check your work if you really want to. Here's the number that I found. I'll store it as, I don't know, a. And then type in negative 2a squared plus 3a plus 8. If it is a root, it should equal 0. Any questions on that first one? Let's try another one. I'm only going to erase part of it though. So for me, there's no point in erasing the equation. I'm just going to change the numbers. Because really, at some point, it's all the same. You're just changing out values. So we need negative b. Now this one's a bit of a twist though. What is b's value? It's not 4, it's negative 4. So what happens when you have a negative? Negative 4, good. You're ahead of me. It's going to be plus 4. We need negative 4 squared minus 4. A in this case is actually also 4, but it's a positive 4. C is the 1. And 2 is, A is a 4 again. Okay, we got to clean this up a bit. What is negative 4 squared? Answer is 16. Now I need to show you guys a common mistake though. If you use your calculator and do this, negative 4 squared, your calculator will tell you it's negative 16. That's because your calculator is dumb. No, it's actually just, it's very literal actually. What your calculator thought you asked to do was to square the 4 and then make it a negative. But what we needed to do is we need to take negative 4 and square the entire thing. You guys know how a negative times a negative is a positive? The most common mistake I see kids make, most common mistake I see kids make, when there's a negative right here, they make it become negative 16, but it's not. This number right here, when you square root it, is always a positive, because a negative times a negative, like the squaring of it, makes it positive. So make sure you don't overly trust your calculator, because that's just 16. And then it's minus 16, because 4 times 4 times 1 is 16, all divided by 8. Oh, I heard someone actually say this already. 16 minus 16 is 0, right? Walk with me through this then. If all of this is 0, what is the square root of 0? 0. Now check this out then. If you take 4 and add 0, is it actually different than 4 subtracting 0? Either way, 4 plus 0 or 4 minus 0 is 4. Because if you take the 4 and you add 0, it's still 4. If you take the 4 and subtract 0, it's still 4. So it's actually possible that sometimes you only get one answer. All of this stuff in the square root sign that becomes a 0, it kind of just all goes away. Because all of that stuff was a big fat 0. And what we're left with is 4 divided by 8. 4 divided by 8 is a half. So there is actually a possibility once in a while with this formula that it'll just magically fit together. The thing under the square root sign will just completely go away, and you might not actually get two answers. You might just get one answer. That's possible too. Try another one. Okay, so for the next one, we just need to put the numbers in the right spots. After a while, it's very similar. We need a negative 5, but don't forget, this number is supposed to be negative b. So negative negative makes it positive 5. This is negative 5 squared. Be very careful though, when you do negative 5 squared, it's going to be positive 25, not negative 25, positive 25. We need a 3 to go here and here, and a 9 to go here. So as I clean this up a little bit here, as I said, negative 5 squared. Make sure you're very careful. The whole negative 5 is being squared. If you type it in your calculator is very literal. It'll say negative 25, but negative 5 times another negative 5 is positive 25. Most common mistake kids make. What's 4 times 3 times 9? 12 times 9? 84? Is that right? 108? 108? 108, okay. Okay, here we have a bit of an issue. As I put this term and this term together and I'm going to subtract them, can I take 25 and subtract 108? Well, okay, you can. You're right, though. It's negative, right? Which then leads to a huge issue. Can I square root a negative number? Okay, so at this point here, here's what I'm going to want from you guys to tell me. There is no answer. It is entirely possible that there is no x that is a positive number, or a negative number, or a fraction number, or a decimal number, or some really stupid long convoluted number. We cannot find any set of numbers that will make this equation true. It's just not physically possible. And so I want you to make sure that you're very clear though. Don't just stop. Don't just leave it right here. If you're going to earn a full mark on a question from me, I want you to clearly indicate that there is no answer, and that you recognize that there is no answer. Because this is a very common scenario that will come up this year. It's actually both across dash 1 and dash 2. Okay. Wait, one last example here, and then we'll take a little bit of a breather and change things up. On this next example, I've thrown in a fraction. It is possible to put the fraction into the quadratic formula. That will work. However, for some of you who did the assignment last week, there's actually a really nifty trick you can play. Do you remember what it is, a way of dealing with fractions? Multiply everything, yeah. By something such that it eliminates your fraction. This 1 over 4, here's what I recommend you do. Times everything by 4, yeah. Here's the reason why this is going to work though. This would only work if we're finding the roots. Because again, what does roots mean? Roots means that y is equal to 0. And if you times 0 by 4, still 0. So this is the advice I'd give. If you ever get like a decimal or a fraction number of your actual quadratic itself, multiply the whole thing to get rid of that. So this is actually going to be 0 equals x squared minus 12x plus 36. No, it's not so bad. Let's start plugging these numbers in. B. B is negative 12. Double negative I is 12. And it's 12. I make up verbs all the time. This B is also negative 12, but make sure you're careful. When you do 12 times 12, it's positive 144, not negative 144. A is 1, C is 36, and A was 1 again. Okay, let's clean this up a bit. Negative 12 times negative 12 is positive. Is with me there? Jordy? Not really paying attention very much. Okay. 12 times 12 is 144. What's 3 times 36? What do I calculate? 108? 4 times 36. No, that's going to be 108. Was it 108? Is it 1? It's 144.
Yeah,
Ah, that's cool. Alright, well, we just did this before, right? What is 144 minus 144? 0, right? So it means that all of this whole thing here, if you add or you subtract 0, it doesn't actually do anything. So in a way, you can kind of get rid of this whole shebang right here. It's all gone. And what we're left with is 12 over 2. 6. So occasionally, the quadratic formula will actually spit out a nice even number. Watch this. Let's say that you didn't know the quadratic formula. We could have solved this without even learning it. This foils into x minus 6, x minus 6. Watch. X times x is x squared. There's minus 6x and minus 6x. That's the 12 altogether. 6 and 6 is 36. And if it's equal to 0, watch this. This would have meant that x was 6. And conveniently, this would have also meant that x was 6. Well, rather than getting 2 answers, we actually got 1 answer twice. That's all. We just ended up getting the same answer more than one way. So the quadratic formula, once you get the hang of it, is very useful for a couple of reasons. If you cannot factor something, it can help you solve the question. Even if you could factor it and you just don't want to because you're tired of factoring, you could actually even throw the quadratic formula in. It would actually still get you the answers that you're looking for. But it's kind of your backup plan. If nothing else is working and you're wondering maybe there are no answers, try the quadratic formula. It will give you normally crazy weird decimal numbers. I am normally more than okay. I actually prefer it. Leave it as this. There's no value in finding the extra decimal numbers, except if you're in my physics class. If you guys in my physics class, why would we be able to make a decimal number? Sig digs. Because we'll have calculated values, and because we have sig digs, we'll know when to round. Does that make sense? But in lieu of that, in math class, we don't have that. Okay. Wait, why don't you guys then see if you can try this one? We're extending now. Ah, there's the. Hey. Yeah. He is not. Okay, well, here's the logical, well, maybe not logical, but here's the extension then. I now want to take the skill that I showed you of the quadratic formula, and we're going to apply it to solving something that looks like this. And then I'll come back to this for those of you who are writing this by hand. But eventually we'll try to solve this. Oh, I guess that's it. So we're now going to try to solve things that are a little more challenging. Think of the Jenga blocks, though. I've really been working with you guys on building a good foundation. What have we started with? We started with learning how to expand. Then we talked about how to factor. the requirements for solving, and the quadratic formula. You guys have all these skills. So think of the analogy I gave you last week sometime. I think of it like a rope. This is a really tangled up rope. It's ugly. So first thing we're going to do is we're going to untangle the rope. That basically means foil everything up. Then we got to straighten out the rope real nice. In order for this whole process to work, what does it have to equal? 0. So once we've untangled the rope, we'll make it equal to 0, make it really nice. And then we're either going to factor if we can to solve, or more likely today, we probably won't be able to factor, so we use the quadratic formula to solve instead. We're going to put all of these skills together. So first thing, let's start FOIL. So if you haven't already beaten me to this, let's get started. X times 3x will give you 3x squared. That'll give you a 9x. You'll also have a minus 15 and a minus 5x. And I really don't care what order those 4 things are in, but you better have all. How should I do with the other side over here? There's 3 things that you need to get multiplied, right? There's a FOIL, but then there's that 3 out front. That'll work. Let's times the 3 in. Okay. So let's make it 3x minus 15. And then we'll FOIL that by the 2x minus 1. That's a good strategy. So we just need to execute it. 3x times 2x will give us 6x squared. We're going to need a 3 times a minus 1 for minus 3x. What else is there? A minus 15 and a 2x, that's minus 30x. And a minus 15 times a minus 1 is a plus 15. We've untangled the rope. Right. It's not quite so ugly looking anymore. But what do we need before we can keep moving on, though? Yeah, combine like terms and make it equal to 0. That's the whole linchpin to this exercise. So we need to put all of our like terms on one side. It doesn't really matter whether you bring all of those ones that way or these ones this way. My personal preference, though, is I always like to have the leading term be positive. That's just my preference. See how there's a 3x squared and a 6x squared? That'll be the one that goes first. So my personal preference would bring these ones this way, because I can kind of see that the 6 minus the 3 will give me a positive number. If I brought the 6 the other way, it gives me a negative leading coefficient. It's still solvable, it's just that's my preference. So I'm going to bring all of these terms that way. So I need to subtract 3x squared. I need to subtract 9x. I need to add 15. I need to add 5x. Because then all of that stuff's now 0. Okay, mental math time. 6x minus 3x is 3x. It's minus 33. Minus 9 more is minus 42. Back up 5. I got minus 37x. Anybody else got that? And a 30. 15, 15, 16. Who wants to factor this one? Numbers that add to give minus 37 and times to give 90. Or let's use the quadratic formula, right? That's actually why it was developed. A, for things that cannot be factored, but B, sometimes we use it for things that are just really hard to factor. And not that I want you to not ever factor, but this would be a good time for it. Even if there are numbers that add and multiply to give what we're looking for, let's not bother. Let's go right to this quadratic formula. Let's see where it takes us. So, minus b plus or minus the square root of b squared minus 4ac all over 2a. That will get drilled into your head, I promise you, because we're going to do it a lot. Oh yeah, start plugging in numbers. We need minus b. B itself, though, is minus 37. So minus 37 means that's just good old 37. B squared is minus 37 squared. Don't forget, though, when you times it together, make sure it's a positive number. Okay, well. A is 3, and C is 30. all over 2 times 3. It's a little intimidating at first, but I mean, once you get the hang of the right steps. Okay, I need some help here. What's 37 squared?
1369.
Thank you. Okay. And what is 4 times 3 times 30? 360? That makes sense. Will we have an answer?
Yes.
How do I know that I will have answers? Because it's not negative. If this stuff under the square root side, if it was a negative number, you can't square root a negative number. That is the one and only time that there is no answer. So there's no answer if this had been a negative number, but it won't be. It's going to be, what is it, 1009? Oh, 6. We're going to stop there. This is equal to a couple of really nasty decimal numbers. Is there any purpose in finding them? Not that I can see. I'm going to do it one more time just right now just to prove that I did it right. But I'm actually going to ask you to leave it right there. But let's just check. I'll check the work on here. So I'm going to take 37. I'm going to add the square root of 1009 and divide by 6. I'm going to get a super nasty decimal number. If this was physics, you guys in my physics class, we would be able to round it because we'd have a sig dig unit to go with, right? But in math we don't, so I'd prefer it like this. Anyways, 11.46. I'll then store it as, I don't know, A, I guess. And now I'm going to recheck both sides. I'll see if they're equal to each other. So here we go. Bracket A plus 3. Bracket. Guys, can you focus, please? Watch. 3A minus 5. This side over here apparently equals that number. Okay. If this side over here also equals that number, then we did it right. So 3 bracket A minus 5 and 2A minus 1. Fingers crossed. Is that last us? Okay, here's hoping. If it didn't work, then we messed up, obviously, right? Questions so far? The learning curve is getting steeper, hey? Like, it all of a sudden starts to take off at some point, where it's not little incremental steps. It's like, this was a big day today. So let's do our one last example here. Let's try solving this. I promise you have the skills to solve it. The question is, can you put them all together? Do you have the adding skills in your pyramid? Do you know how to deal with fractions? Do you know how to FOIL? Do you know that quadratic formula? So as you're writing it down, let's talk about a few of the things that you're seeing there. At some point, hopefully you see, you're going to have to FOIL, right? There's some stuff to FOIL. There's also a fraction. How do you deal with fractions? Times it up to the other side. Yeah. So at some point, we're going to times that x plus 2 in brackets. We're going to deal with that by timesing it to the other side. I like the rope analogy. This is a really, really twisted rope. There's a big knot in this thing. A fraction knot, an expanding knot. What we need to do is we need to FOIL everything we can possibly FOIL. And then at some point we need to make it equal to 2. That's our first set of goals. So why don't we start by FOILing what we can FOIL? So right here we've got, let's see, there'll be a 3x, right? There'll be a 5x squared. There's going to be a 9. What did I miss? This one here. 5 by 3, 15x. What else can I FOIL? Well, the bottom doesn't really have anything to FOIL with. There's one more thing that can do, like not a full FOIL, but like an expanding of some type. Yeah, this little bit right here, is that what you're looking at? Yeah, we can FOIL that little bit. So let's make this equal to minus 2 plus 4x minus 4. And this thing on the bottom of the fraction here, I'm just going to leave it there, x plus 2. Because it doesn't have anything to FOIL with yet. Okay. Reach into your toolbox. What other tools do we have at this point that we can do? Like terms. Good job. Who said that? Good for you. Yeah, let's put like terms together. Okay, so up here, 5x squared, I guess it's by itself. The 3 and the 15 go together though, right? Yeah. This 3, this 15, that gives you 18x. There's a 9 left over. And over here I can put some like terms together. You'll have a 4x and a minus 6. But I still have the stupid x plus 2 sitting at the bottom. So, rope analogy. First step, I foiled the crap out of this thing. There are no more brackets that need to be foiled. I combine like terms, but I still have that fraction. There's just one more knot tied inside there, right? So, how do you get rid of the bottom of a fraction? Times it up to the top of the other side. So what you're going to have is 5x squared plus 18x plus 9. And this 4x minus 6 has to times by x plus 2. How do I write that, though? Well, I would put it in brackets. The 4x minus 6 has to times by the x plus 2. Which means we got to FOIL it again. Ah, there was another knot tied in there, and I have to straighten that one out. That makes sense? So we have to do another FOIL. Yay. You can see why we spent some time on it, eh? Okay, 4x times x is the 4x squared. There's a minus 6x in there. There's an 8x and a minus 12. By the way, I want to point something out here. At some point here, I'm going to, like on foiling like that, I'm not going to go through it little by little step. At some point, I'm just going to go right to the answer. If foiling is something that you struggle with, and as I go through that step, you're like, too fast, too fast, too fast. We need to work on that in your practice journals, right? Like that's something that we need to keep working on, that skill, because it's only one of a million pieces in that Jenga puzzle, right? I need you guys, I'm going to say this so much, I need you guys to identify where those weak spots are and target them, right? Because if there's a piece to this big, long problem that's like pages long that you know you're missing, we need to fix that, right? We can't have holes sitting in there. Let's make this equal to 0. I think I'm going to put the 0 on this side. I'm just going to throw all these terms on the other side. So I need to minus 4x squared, add 6x, minus 8x, and add 12. And if I do that, I've thrown everything on the other side. Okay, combine like terms. You're going to have an x squared. 18 minus 8 is 10, add 6 would be 16. And 9 and 12 would give you 21. Alright, how do I solve? Well, we can factor. We need numbers that add to give 16 and times to give 21. I don't think that actually works. So, quadratic formula. Minus b plus or minus square root of, I'm getting sick of this, right? No? A little bit. You will get sick of it. I'm sorry. But hopefully you'll see, though, it's a really good plan B, C, D, right? Whatever it happens to be. It's a good backup method for if factoring is not possible, there may be a solution. It's just the solution might be really dumb-looking decimal numbers. That's all. So, negative 16 plus or minus 16 squared minus 4 times 1 times 21. All over 2 times 1. I'm going a little faster there, too. Slow down in case you didn't get there. It's not my greatest 16 squared ever. Let's do 16. All right. 16 squared, 256. 16 squared. Anybody do that one? 256. Okay. 4 times 21 is 81. 84. Ooh, thank you. Who said that? 84, right? My brain is failing me. What's 256 minus 84? Someone help me. 172? Okay. Minus 16 plus or minus the square root of 172 all over 2. And guys, I am cool if you leave it there. There are two answers in there. They are two very ugly decimal numbers, which is why we couldn't factor it. It probably does factor, but it's like x plus 9.37251, x minus 2.41, you know what I mean? So when we do word problems that involve sig digs, like in a physics or chemistry setting, we will use this formula, by the way, and we will take it past this step. But for you guys here, I just want you to stop there. Quick bit of summary here before we take off for the day. So, what have we learned? We've done 4 lessons so far. Okay, well, let's go in order. So, first lesson we learned was just our basic algebra. I need you guys to be able to know how to subtract 3x from one side, divide both sides by 4. That's a skill you better possess, right? The second day's worth of notes, we learned how to FOIL things. Again, when I'm FOILing here, and I'm going a little bit faster and a little bit faster, if that's something you're struggling with, you gotta put some practice in, okay? I'll help you with it during focus time, but it's gotta become second nature being able to do that stuff. It really does. After you're done FOILing, yes, just hold on one sec, you're gonna go in a minute anyways. After you're done FOILing, you need to know how to factor it back together again anyways. So if you struggle, and especially once I hand back your assignments in a second, any of the types of questions where there is a leading coefficient like this, like that one right there, don't forget you have to split the middle terms into 2, because a lot of you are missing that. And then the last thing we talk about today is, what if you can't factor? What if it's not that you made a mistake, what if physically it is impossible to factor? This quadratic formula is your backup option. It's long, it's a little bit lengthy. I haven't even shown you how we got it. You're just taking me on my word right now. But it is something that can help you solve a quadratic if you're stuck.